Node.js uses V8 as its language processor, so we have to think in V8 specific terms when optimizing code. Some optimizations work across V8 versions, others don't. V8 is constantly improving, and an optimization that mattered yesterday might be worthless or even counterproductive tomorrow when V8 fixes the underlying issue. Let's start with hidden types. JavaScript has dynamic types, which means a variable can change from a number to a string and back. This feature is hard to optimize at compile time. V8 addresses this with a feature called hidden types. When objects of the same constructor don't undergo changes in their prototype, they all share the same hidden type and use the same optimized code path. For example, if you create two person objects from the same constructor, and both have the same properties set in the same order, they share a hidden type. The moment you add a property to one that wasn't set in the constructor, like setting Jane.age after creation, that object diverges from the shared hidden type. V8 can no longer use the same optimized code for it. For simpler objects, you can enforce shared hidden types by setting all properties in the constructor and then sealing the object. Now for numbers. Since JavaScript has dynamic types, numbers can change type too, from 31-bit signed integer to double precision floating point. The compiler infers the type and tags the variable accordingly. Changing the type after that is possible but expensive. The key rule: avoid getting in and out of 31-bit signed integers. Once a number crosses the 31-bit integer boundary, for example, by dividing to get a float, it becomes a double precision float and can never go back efficiently. Now for arrays. Arrays in V8 have internal types for each specific element type. The compiler keeps arrays efficient by tracking their element type. Switching between element types in the same array forces internal type conversion expensive. Keep array elements the same type. Also, avoid deleting elements in the middle of an array, avoid accessing elements you didn't initialize, and if you know the size of an array, point it out when creating it. And most importantly, initialize arrays up front with literal syntax var a equals 32, 3.2, false, instead of setting elements one by one, so V8 knows the hidden type immediately. Functions in V8 inherit from objects, so hidden types apply to functions as well. Polymorphic functions, functions that are called with different types of arguments, will degrade performance substantially. If you want the best performance, create a separate function for each constructor you need, rather than writing one function that handles multiple types. For example, an add function that you call with numbers looks monomorphic to V8. The moment you call it with strings, V8 now has to handle two types and can no longer specialize. Also, be very careful with the arguments object inside functions. Some uses of arguments are performance killers. Never reassign arguments, for example, arguments 0 equals something. If you need a default value, use a separate variable instead. You can safely use arguments to check the length and to access valid indices, but that's where it ends. The for-in loop has performance penalties. When iterating over object properties, use object.keys to get a list of keys, then iterate with a regular for loop. This avoids the edge cases where the compiler simply cannot optimize. The pattern is var keys equals object.keys, obj, then for, var I equals 0, I less than keys.length, I plus plus, access obj, keys, I. Never use for-in when you care about performance. Infinite loops, while true, or for winky face, should never appear in your code. They are essentially impossible to optimize, and if you find yourself needing one, it's a signal that your logic needs to be refactored. Try-catch blocks are important for capturing exceptions, but the compiler has difficulty optimizing the scope inside a try-catch statement. Move as much code as possible outside the try-catch block, keeping only the minimum necessary inside. Finally, eval, avoid it at all costs. Any function scope with an eval call becomes unoptimizable by V8. If you absolutely must use eval, and you almost certainly don't, put it in the smallest possible function scope to contain the damage.